Good afternoon. Good afternoon, everyone. Welcome to the final session of this course, this NPTEL course on the joy of computing using Python. So today will be our last and final session before you have the exams. So as we were discussing yesterday, this week we will be focusing on revising some of the important concepts that we have been learning in these 12 weeks. So yesterday we started by looking at some questions. We did about 13 questions yesterday, and I plan to do 13 more questions today. So we will carry forward from where we left yesterday. So for those of you who are joining for the first time, here is the link to the YouTube channel where you can go and watch all of these live problem solving sessions. And even if you have missed some of the previous week's sessions, you can go to that YouTube channel and watch them over there. And also some people face some bandwidth and network and connectivity issues in Zoom. So to them I would suggest that they also uh, basically join the YouTube live streaming link on this YouTube channel. Okay, so with that out of the way, let us get started one final time. So this is the first question for today. Let me start the poll. So we need to predict the output of this code. So as we have been seeing yesterday as well, this week all the questions are basically programming based questions, predicting the output of codes, and then we see by writing these codes in Python. So the focus is on programming so that we revise as many concepts in programming as possible. Okay, so all of you please take about a minute to answer the poll. So here in this question, we have two lists and then we have nested for loops and some if else conditions. Okay, so let me stop the poll. The correct answer to this question, as all of you rightly selected, is to print unique movies of list L1. So let us now write this code in Python and see it for ourselves. So this was the question from yesterday. Let me remove this. And let me write the question for today. So we have two lists over here which contain names of movies. I haven't watched even a single one of them. I hope all of you would have watched at least some of these movies. Okay, so here are the two lists, and then we have for loops. Then we have another for loop, nested for loop. Then this break statement is used to come out of the loop. Okay, so here is the piece of code. Now we need to print it. Let's see. So we see the output is Harry Potter, Avengers, and John Wick. Now these happen to be the unique movies in list L1, because if you see, uh, Harry Potter is not there in list L2, Avengers is not there in L2, and John Wick is also not there in L2. Whereas Matrix and Spider-Man, these two movies are there in list L2 as well. So this piece of code prints those movies in list L1 which are not present in list L2. Okay, so let us come back. Now we will move to the next question. This is also a question in which we have a list of some movies. So please attempt this question, then we will discuss it. Here also we are making use of the random module which we saw yesterday as well. So please take about a minute to answer. Okay, so let me stop the poll. So the correct answer, as most of you rightly selected, is option C. It displays the number of vowels and the name of the movie. Now we see this command elif. So elif, I'll just revise for you, stand is a short form of else if. So instead of writing else if so many times, we can use this elif. So we have if, and after that else if. So else if is shortened to make elif, and then we have other such elif conditions, and then finally we can have a last else condition. So the way we to use if else conditions is, you can have if one condition and then something and then else and then some piece of code, or you can have if then a condition, some code, then elif, some condition and some code, and then finally else, the condition and some code. You can write in this way also, or you can write in nested way. So you have if, then you can say else if some condition, then some code, then inside this you can have else if, and this way you can nest your if else conditions. So these are different ways of using if else. So here we are uh, checking all these vowels A, E, I, O, U, both capital as well as small. So whenever we encounter these vowels, we are incrementing count by 1. So basically we are counting the vowels, and then we are also printing the name of the movie. So not just count, but also the name of the movie is being printed. So let us write this in Python. So we don't need L2. We need to import random. Then the name of the movie is Harry Potter, Matrix, Spider-Man. Then instead of this, we have Terminator and then Karate Kid. We need the count variable to be initialized to 0. And as I mentioned yesterday, we can write this in shorthand notation as simply count plus equal to 1. This is same as saying count equal to count plus 1. Now let me copy this and paste it to save my effort. Then all the vowels need to be counted. and then we need to print count and movie. See, so it randomly chose one movie out of the list of movies. So it chose Harry Potter, and the total number of vowels in Harry Potter is 3. So we have the first vowel at A, Harry, in Harry. Then the second vowel is O in Potter, and the third vowel is E in also in Potter. So if we run it once again, this time the random movie chosen was Terminator, and in Terminator we see that there are 4 vowels: E, I, A and O. So this is the way this code is working. Okay, so we can move ahead. Let me relaunch the poll. What is the code to generate all prime numbers between 0 and 100? So a prime number is a number which has only 2 factors, 1 and the number itself. So prime means only 2 factors, which are 1 and the number n itself. So if some number n is a prime number, then it has these 2 factors. If it has any other factor other than 1 and the number itself, then it is not a prime number, and then it is called a composite number. So all of you please try to attempt. Okay, so let me stop the poll now. So most of you got this one wrong actually. So the correct answer to this is option B. Now some of you most of you selected option D. Now the problem with option D is in range 101, the first number is 0. The range function always starts from 0 when you write it in this way. So 0, 1, 2, so on and so forth. Now 0 divided by anything, that will always give you 0. So 0 divided by n is always 0. Okay. And so remainder will be 0, quotient 0, everything is 0. So as a result, it will show 0 as a prime number. But we know that 0 is not a prime number. 0 and 1, by definition, they are not prime numbers. The first prime number is 2. So we need to start from 2 and not from 0. So that's why B is the correct option. So let us now run this in Python. So let me remove this. So this is the piece of code. Let us run this. Oh wait, something is wrong. Oh sorry, I wrote print 9 instead of I. See, we see all the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, so on and so forth up until 97, which is the last prime number in the range 0 to 100. So all of these numbers are prime numbers, meaning they have only two factors. So let's say 17, 17 has only two factors, 1 and 17. That is the number itself. Okay, so this is for printing prime numbers. A faster way to check whether something is prime or not. So here what they are doing is they are scanning from 2 to the number. So let's say if I have the number 25, then I will start by dividing 25 by 2, 3, 4 up until finally 25. Okay. Or sorry, 25 minus 1 because this is in range. So up until 24 I will divide and check whether these are factors or not. So it is starting from 2 going up to I minus 1. So this way it is doing. But a simpler way and a much faster way to, not, I would not say simpler, but a faster and quicker way to test for whether some number is a prime or not. So these are called primality tests. So there are many primality tests. So one of them is that you start from 2, but you go up to square root of that number and the integer just next to the square root of the number. So up to, I would say, int square root of n plus 1. So 1 more than that, because that is, so if square root of something is like 5.34 something like this, then you would go up until 6. So in our case, for 25, square root of 25 is 5. So we will check by dividing. So let me remove this. So we will check whether 25 is prime or not by dividing 25 with 2, 3, 4 and 5. And we see that the moment we will come at 5, we will realize that 25 is divisible by 5. So it is not a prime number. We do not need to check for 6, 7, 8, 9, 10 because we already found one factor which is not 1 and not the number itself. So we found a third factor for this number. That means it is not prime. So we need not go up until 24. So this is one such primality test, and it is quicker because you don't have to test for so many other numbers. Okay, so we can move ahead. What is the code to replace all the letters of a movie name except special characters with with star in a single line? So let me restart the poll. So we want to replace all the letters in the movie except for special characters. And what do we want to replace the letters with? We want to replace it with asterisk. That is this star shape, star character. Okay, wait, something is going wrong. I think, give me a minute. I think something has gone wrong. Let me reconnect this. So now I think the text is a little bit better. Okay, sorry for that technical glitch. I think it is better now. So let me scroll up. And let me, yeah, so fine. This is better. So please try to select the option. In the meanwhile, someone was asking about what is flag. So flag is nothing but a variable. So in the previous questions, we saw this variable flag. Okay, we saw this flag, this variable flag. So flag is just a variable. It's a variable that you use to keep track of the output of certain commands and certain statements. So here we have the variable flag, and then what are we using it for? We are using it over here. So the moment we find a factor, so if in this line we basically find a factor which is other than 1 and the number itself. So the moment we find a factor, we set flag equal to 1. That means this number is not a prime number. See, we are printing when flag is equal to 0. So when flag is equal to 0, that means we have a prime number. But the moment flag becomes 1, then that means it is not a prime number. So it's just a variable to keep track of whether some statement is true or false. So here it is used to keep track of whether a number is prime or not. So we are checking for primality of a number. So if it is prime or if it is not prime, to keep a track of that true false kind of statements, this variable flag is used. It's just a variable, so you can call it anything of your choice. Okay, so coming back. Okay, so let me stop the poll. So the correct answer is option B, which unfortunately none of you selected. So this is the correct option. And let us now write it in Python. Oh, sorry. This is not the correct option. Wait. This is the correct option, the one which has this end equal to thing. So this is the correct option, which nobody has selected. But let us see why this is the correct option. Let me go back to Spider. Okay, someone is asking the purpose of end equal to. So it will become clear with this example. So let me write it in this piece of code in Python. Then it will become clear to you what is end equal to doing. Oh, I should have kept that list of movies. Oh, it's not there anyway. Fine. So, okay, these are the movies in the list. Then we have a variable which contains all the letters. We are making use of the string module, and then we are adding to it the list of all numbers as well. And then we will randomly select a movie name with this random command, random.choice. Okay, let me run this code. So, okay, so the problem with this is, let me print the movie name as well. See, it selected Harry Potter and it has replaced, so because there is no special character other than space, so space is the only special character, so it has replaced all the other characters. So HARRY, that is 5, so we have 5 asterisks over here. And then for Potter, POTTER, that is 6, we have 6 asterisks over here. So because there is no special character, all these except the space, then everything is replaced by this asterisk. Now I want Spider-Man to be selected because Spider-Man has that hyphen in between. Yeah, see, Spider-Man is selected now. In Spider-Man, there is this hyphen in between. So apart from that hyphen, which is a special character, everything else is replaced by asterisks. Now, someone was asking what this end equal to does. So let me remove this end equal to, and then you will understand what is the purpose of this end equal to. So if I remove this end equal to, you see what happens? Everything gets printed in a new line. Every iteration. So what happens is, whenever you have a loop and you have prints command inside the loop, then for every iteration of the loop, the command, the print statement prints in a new line. But if you do not want to print in a new line, then you make use of this end equal to, and what it does is, instead of going to the new line, it does not go to the new line, it prints in the same line. So now if you see, it prints in the same line. A simpler example let me take. So let me remove all of this. Let me just have a simple loop. Let's say I in range 5. And I want to print I. Okay, this is the simplest loop I can think of. Now see what happens. It prints 0, 1, 2, 3, 4. All in different line. Now if I do end equal to and this blank character, you see it all comes in same line, 0, 1, 2, 3, 4. Now if I want a space between each number, I will put space, end equal to space. See, now it comes with a space between each number. Now let's see if I want to print star between each number. So end equal to star. Now see, it prints star after every number, after every iteration. So this is what this end equal to command does. It prints this character after each iteration of the for loop. And if I remove it once again, you will see everything goes to a new line. See. So I hope that clarifies the doubt on end equal to. Okay, so now we can move ahead. What's the output of the following code? So it's just one line of code. Very simple. Let me relaunch the poll. So just one line of code. Take a few more seconds to answer. So some people are answering in the chat box. I request all of you to please answer in the poll itself. Okay, so let me stop the poll and share the result. Okay, so most of you selected the right answer. The correct answer is list of squares of even numbers. Now, when we write this in one line, it is what is called as inline statements. So, inline for loops. And this one line of code is essentially equivalent to the following. A few lines it will require. See, so we have like what? 1, 2, 3, 4, 5. So 5 lines of code is being replaced by this one line of code. So this one line is essentially equivalent to these 5 lines of code. So it simplifies the code in the sense that it requires less number of lines. So that's one benefit of using these inline statements. So let us now run it in Python. So this is the single line. See, it prints the squares of all even numbers. So 0 is even, 0 squared is 0, 2 is even, 2 squared is 4. Then 4 is even, 4 squared is 16. Then 6 is even, 6 squared is 36. Then 8 is even, 8 squared is 64. And 9 is not even, 9 is odd, so it does not print 9 squared. Now, as I mentioned, this is equivalent to these few lines of code. Let me show that equivalence as well. Okay, so let me run this. See, it prints these 5 lines of code also print the same output. So we see that this single line over here is equivalent to these 5 lines over here. Okay, so now we can move ahead. What is the correct code to calculate the sum of the given series? So let me relaunch the poll. Okay, so let me now stop the poll. Before that, there are some questions in the chat box. So, Elango, you have written some code in the chat box. Could you please unmute and tell me exactly what is your question? Oh, thank you, Elango. Okay, so thank you very much for making my life easier by writing the code in the chat box. Okay, so let me go to Spider. So some people were asking what platform I'm using to write the code. So this is Spider in case you are not using this. You can use any other platform of your choice, let's say Jupyter, but yeah, this is Spider. This Outlook, this framework is for Spider. So this is the correct code. Let me run it. So let's say I want some for, let's do first three terms. So this is 10. So 6 plus 3, 9 plus 1, 10. So correct. Let's do four terms. Okay, let's do simply. Let's do one term. That should be 1. See, it is 1. Let's go step by step. Then let us now do two terms. This is 4. Correct, because it is 1 plus 1 plus 2. That is 4. 3 we already saw is 10. That is 1 plus 1 plus 2 plus 1 plus 2 plus 3. So that is 1 plus 3 plus 6. So that is 10. Let's do one more. Let's do 5. So this is 35. So let's see. 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4. 10 plus 6, 16. Okay. Plus 1 plus 2 plus 3 plus 4 plus 5. So we can print it over here. Let's do 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4 plus 1 plus 2 plus 3 plus 4 plus 5. This is the first 5 terms. See, output is 35. So this code is working correct, and the correct option is, oh sorry, I think I did not mention the correct option. So let me now mention the correct option. You have already seen the correct code. So the correct option is option C. Now the last MCQ question, and then we will move to programming based questions. So let me start the poll for one last time. Okay, the very last poll. All of you, please attempt it. This is the last chance that you are getting. So this is a question on perfect numbers. So a perfect number is a number in which the sum of its proper divisors is equal to that number. For example, 6 is a perfect number as the sum of its divisors 1, 2, 3 is equal to 6. So when we say proper divisors, this excludes the number itself. Okay, that is what a proper divisor means. Okay, so let me stop the poll. The correct option is option A. And let us now see this in Spider. So we need to define the function. So as you know, for user defined functions, we use the keyword def for defining. And as I mentioned before, you could use the shorthand notation that answer equal to answer plus I. You could replace that with answer plus equal to I. Okay, so now let me call it with some number. So let's try with 6 because we know 6 is a perfect number. See, it prints true. 6 is a perfect number. Let's do with 5. So 5 is not a perfect number. That's false. So what are some other perfect numbers? Let's try one by one and see after 6 what is the thing. So now see 6. 6 is a perfect number. I don't know what will be the next perfect number. Can someone think of it? I mean, I'm just trying. Okay, let's do one thing. Let's run this in a loop for the first 100 numbers. Okay, so let us try running this. So yeah, someone mentioned in the chat box that 28 is a perfect number. And indeed, you are correct. We see 6 and then 28. So 28 is a perfect number. So we have only two perfect numbers in 1 200. Let me go 1000. Okay, this will... Oh, we have only three numbers. 6, 28, 496. So very few perfect numbers. Okay, in 10,000, still the same. No, okay, fine. Four numbers in 10,000. Fine. So these are a few perfect numbers. So that's all for the MCQ questions. Now we will move to the programming type questions. Okay, so Diksha has posted a question in the chat box. Diksha, I had responded to this question on the YouTube video as well, where you had asked. So I had given a first look, very cursory look at this question, and I would check it once again. So thank you for reminding this to me. So I will check it once again and then I will let you know. Okay, so let us move.
Good morning, ma'am. Good evening, ma'am.
Yes, yes.
Actually, in that is an assignment question where the answer is 5.
Yeah, so when I checked, I was getting 6. So now you are saying the answer is 5. So I will check it once again.
Okay, but basically how to do it, ma'am?
Oh, so
Is
this
there...
is this question means that you have to go from 1 to 100 in
Okay.
the least number of throws of the die. So I think I took one extra move thinking that we start from outside the board. Maybe the instructors mean that they start from 1 like on the board. So I was thinking like I'm outside the board and then I will take one turn to land onto the board and then move ahead. So maybe that's why I took one extra move. But anyway, the meaning of this question is that you have to roll the die least number of times, meaning you have to be the luckiest person in the world. So what do you mean by luckiest person in the world? That is, you follow all the ladders that are there. Okay, so each time you roll a die, you land up at some big ladder. That means it takes you from a very small number to a very high number. You have to optimize that and you have to select those ladders which offer the biggest jumps. So that is the thing. So this is that kind of a question. I would say it's
Okay.
pretty much like a meaningless question, but anyway, if you do 2 3 trials, if you just see which are these ladders. So let's say the first ladder, it goes 3 to 20. So you just try, like first roll you will get 3, then you will land at that 3, then that goes to 20. Then after 20, what is the next ladder? Next ladder is at 22, so you need to get 2 to get that ladder. So that's the thing.
Okay, thank you, ma'am.
Okay. So now we move to programming type questions. So the first question is, there is a list L containing some numbers. Write a program to create a new list which contains the numbers which are either divisible by 5 or 7 or both. Print the new list in ascending order. So this is, we need to check divisibility. So the example is given. So we have a list 7, 8, 9, 10, 11. So we see that 7 is indeed divisible by 7 and 10 is divisible by 5. So that's why the output list is 7 and 10 in ascending order. So let us write the code. So we will have L, which will be some input list. Then we will have, let's say, some new list, let us call it. Then we will scan every element of the list L. Then we will check whether it is divisible by 5 or by 7. In both the cases, we will add it to our new list. And then we need to sort it. And then finally, we will print it. Okay, so let us write this piece of code. So let us take an input list. So let us take the example. Okay, so let us run it. See, we get the desired result. And if let's say I keep 35 here, see, it is 7, 10, 35 as expected in the ascending order. So this is working fine. This is the code for achieving this problem. Okay, Elango has given some other method. Okay, Elango, let me copy paste your code. So this is Elango's code. So let me just run this. So Elango, the problem with this code is, as you can see, we are getting this extra number 9 as well. Okay, which we do not want. And it's not removing. Okay. So what you're doing is you are sorting the list first, which is fine. You can sort the list initially, or if you want, you can sort it later on. Either way. And then what you are doing is you are checking this. So if the number, if we divide it by 7 and if the remainder is not 0. Now the problem with this is if you divide 9 by 7 and the remainder is definitely not 0. So you are getting confused about being divisible and being not divisible. So if a number is divisible by 5, and if you want to negate that, so you want to keep only those numbers which are divisible by 5 and 7 in the list. You do not want this extra number 9. Now, according to your logic, 9 is definitely not divisible by 5 or 7. So if I do this condition, if I modulo 7 is not 0, and then you are saying and I modulo 5 is also not equal to 0, then you are trying to remove those numbers. So this way this thing is not really working. So Elango, do you have any other question?
No, ma'am. No.
Okay, so yeah. So I hope you understand that something being divisible and something not being divisible are those things. Okay, so let us move forward. Okay, someone else has some other question. Will you explain the problem of ladder once again? Okay, Smita, that problem of ladder is nothing complicated. It is just about the game of luck. So the ladder question is that if you are the luckiest person on this planet, then how many turns would you require, the least number of turns that you would require to reach from start to end in the snakes and ladders game? Now, what this means is that you should not get bitten by any snake and you should get a ladder at each step or almost at each step. So you have to see that you make use of maximum number of ladders, and not just maximum number of ladders, but those ladders which offer the biggest jumps. So that you have to see and do a little bit hit and trial and figure out the path. Okay, so let us move forward. Okay, so let's move to the next question. Write a function which takes a list L and integer n and print the first n largest numbers of the list. So what we are taking is a list n and an integer n, and we want to print the first n largest numbers in the list. And we need to do it by writing a function called rev. So let's define the function. And because we want the first n largest numbers, so we will sort the list in the reverse order. And then this is how we will use slicing or indexing of lists to select the first n largest numbers. And then we will print the list. So what we can do is we will have an input list. Then we will take n as the input from user. Then we will just call the function. Okay, so let's go to Spider. Okay, so here is the function. Let us run it. Let's say I want the first three largest numbers. So it gives 35, 11, 10, which is correct. And if I print the list, you see this is the list sorted in reverse order. That means largest number is first and smallest number is at the end. So this is how you would do. So coming back, next question. Write a program to count and print the number of odd numbers in a list L. So we will have an input list. Then let's declare a count variable. And then we need to count the number of odd numbers. So very simple. So this count plus equal to 1 is shorthand of count equal to count plus 1. And let's print it. So it says 4 odd numbers. So what are the odd numbers? It is 35, 7, 9 and 11. So these are 4 odd numbers in the list. So it is working perfectly fine. Okay, moving on to the next question. Take two numbers n and k as input. Create a list L of length n and initialize it with zeros. Change the value to 1 of even indices if k is even. Otherwise, change the value of odd indices and then print the modified list. So let us start is this. In this, we will use the NumPy module. So NumPy is one of the most important modules in Python to work with arrays. Then we will take the input from user and typecast it to int. Then we need to create a list of length n and we need to initialize it with zeros. So what I will do is I will make use of this np.zeros function. And then let's make use of a flag variable to keep track of whether it is even or not. So if it is not even, then flag is set equal to 1. If this k is not even. So if flag is 0, that means k is even. So this means that if k is not even, that is k is odd, then flag is 1. So what the question asks us to do is that if the user has given an input k which is even, then we need to replace the even indices by 1. So that is what we are doing. And if the user has input an odd number, so if k is odd, that is if flag is not 0, flag is 1, in that case we will replace the odd indices by 1. And then finally we will print the list L. Okay, so here in this question you are seeing the use of this NumPy module, which is very important. So there are a few modules in Python which you would use pretty much frequently if you ever work with Python. One of them is NumPy. NumPy is like the bread and butter of working with arrays. And the other is matplotlib. That is for visualizing, plotting any graphs, any kind of plots or visualization that you would want to do. The standard for that is matplotlib. So these are the two most important and basic functions, modules in Python. So Elango has...
Hello, ma'am.
Yeah, hello. Yes, go ahead.
Hello, ma'am.
Yes.
Can we write the same program without using NumPy? Actually, what NumPy plays here, ma'am? What's the role of writing here?
Oh, NumPy does this thing, this line. Okay. There's this built-in command np.zeros which initialize an array with the number of zeros, so n number of zeros. So if n is, let's say, equal to 3, then what you would get is L as this. You can do this without numpy. So for that, what you would do is you would do without numpy. If I do without numpy, then I would have initialize L as an empty list. Then I would run a for loop for I in range n, and then I would do L dot append 0. These 3 lines are essentially what this built-in command is doing. Okay.
Okay, ma'am. Okay, ma'am. Thank you.
So I just wanted to introduce, means not introduce because you have already seen this. I just wanted to revise this module. That's why I'm making use of this NumPy module. Okay, so let us write it in Python. So this is the code. Let us run it. So first I need to enter n, let's say 5, then k, let's say 3. Then this is what I get. So since 3 is odd, it replaces all the odd indices by 1. So 1 at the index number 1 and then at index number 3. If I run it once again, this time if I enter 2 for k, then see the even indices are replaced by 1. So first index 0, then index 2, then index 4. So this is what we wanted to achieve and it is working. So Elango has given some other piece of code. Let me run that as well for you. So this is Elango's code. Let me comment out my section. Okay, so okay, so let me run this. Let me again enter the same 5 and 3, and we are getting what we wanted, 01010, which is good. And then let me run once again, 5 and 2, and we're getting 10101, which is what we want. So this is also another way, and very good. Means you people are thinking of different ways of writing, of solving the same question. So there can be like multiple ways of solving any given problem, not just one way. You can think of different ways of writing the same code. So someone was asking how to do it without using NumPy. So here is one another example that Elango has provided, which is not using NumPy. So yeah, I just wanted to demonstrate to you what NumPy can do, one of the functions of NumPy. So that's why I use this NumPy. Okay, very good. So someone is giving one another example. So let me show that as well. Someone is giving, let's go back. Let's comment this. Okay, I don't need to comment it. Let me put it here in the console. So someone gave this way of initializing as well, which is very good. So yeah, I am happy that people are thinking of different ways of achieving the same. So this is also one way you can you can create a list of n zeros. So if we have n, then you would say this into n, provided you take n as the input from the user. So this is also one way of initializing a list. So very good. I'm happy that all of you are thinking of different ways and different ideas. Okay, so let's move ahead. We have two more questions. Write a program to take string s as an input and replace all the vowels by star. Print the modified string. Okay, so let's say we have a variable called vowels. And then we will take an input string. So by default, the input is a string. So we don't need any type conversion. So if it is a vowel, then we need to replace it by asterisk, that is this star. And we want the output in the same line. So we will make use of this end equal to command. And if it is not a vowel, then we don't do anything. So very simple piece of code. Okay, so let us run it. Let me enter any string. Let's say string. See, there is only one vowel I, so it replaces that with a star. So let me try something else. Let me do random string. See, it replaces all the vowels A, O, and I. And lets everything else, including this space, be the same. So this is working as desired. So now we come to the very last question that we will discuss. Not just for today, but the last question of this course that I am going to discuss with you, of the last question of our live sessions. So this is a question of printing a star pattern. So write a program to take an integer n as an input and display the following pattern. So if the input is 3, then we have this kind of a pattern. So we start with 1 star, 2 star, 3 stars, and then decrease to 2 and then 1. So this is the kind of pattern that we want to achieve. So let us open Spider for one last time in this live session. Let's get rid of all of this and write the final piece of code. So we'll take n as an input from the user. Oh, sorry. I should write it first on the pen and paper. Okay, so let me write the piece of code first. So we'll take n as an input from the user. Then we'll run a for loop. All of you are free to think of your own ways of achieving this. I would be very happy if you come up with some other way. So right now, this is what I can think of. So let me see if what I have thought is indeed correct or not. In the meantime, all of you, please think of your own ways of writing this. Oh, sorry, I had to put it like this. Okay, so let's try. See, it is printing. Oh no, something is error. It is not printing 2 stars. Okay, so what is happening? Okay, so there is some error which I think I have figured out. So let me print this. So this is how you would debug code. So if there is some error, then you would target different segments of the code. And then debug. So right now I'm debugging because I'm not able to generate the second half of the star pattern. So that's what I'm trying. Okay, so let's try. Still there is some error. Okay, so let's do one thing. Let's print I and see what is happening. Okay, I get it. So just give me a second. I will fix this. I got the thing. So let's go back to the pen and paper and fix this. And then fix it in Spider as well. So this is what happens if you are just writing the code for the first time. You can make mistakes, things will go wrong. and then you need to figure out what has gone wrong. So step by step, you have to uh, try each line of the code and figure out where you have gone wrong. So see, what is happening is, up until here, we can go I plus 1. So if I is 0, then I plus 1 is 1. Okay. And then next step, I is 1. Then I plus 1 is 2. That is fine. Then next step, I is 2. So I plus 2 is 3. That is fine. Now next step, I is 3. Now from here, we want the output to be 2. And then I next step will be 4. And we want the output to be 1. Okay. So what we need to do is, we have 2 times n, that is nothing but 6. So 6, because n is input is 3, that means n is 3. So 6, and then we need to 2n minus I we will do. So 6 minus 3 and then minus 1. So this is 3. And here if we do, so sorry. So we have 2n equal to 6, and then if we do 2n minus I minus 1, so that is 6 minus 3 minus 1, which is 2, perfectly fine. And then what we will do next line, so 2n minus I minus 1, this is nothing but 6 minus 4 minus 1, which is 1. So this is what we want. So we have achieved it by this 2n minus I minus 1. So this is what we need to write in our Python code. So let's go back to Spider and fix it. Okay, so let's go back to Spider. Where is my spider? Yeah, here is the spider. So I have fixed the code for you. So now if we run it, so if we enter 3, so we get the desired pattern: 1 star, 2 star, 3 star, then 2 star, and then 1 star. Then let's try some bigger number. Let's say 5. So 5. Then we see, yes, 1, 2, 3, 4, 5, 4, 3, 2, 1. So it is correct. So let's get rid of the unnecessary extra lines. This is also unnecessary. This is also unnecessary. Okay. Let's enter 3. 1, 2, 3, 2, 1. Perfect. Let's enter 4. 4. So 1, 2, 3, 4, 3, 2, 1. Perfect. So this is working as we want. So this is fine, and I will fix it in the lecture notes for you so that when you access it, you have the access to the correct code. Okay, so this brings us to the end of this course, The Joy of Computing Using Python. I hope all of you have enjoyed the course as much as I have done. Okay, some people have some other suggestions. Let me check. Okay, let me try other people's code. So this is my version of the code, which is working fine. You people can have your versions of the code. Let me test out your versions of the code. So this Elango has given. So let's remove this taking input and let's have it here itself. I am too lazy to take input. So let's try this. Perfect. So this is working. Let's try some other number. 1, 2, 3, 4, 5, 4, 3, 2, 1. Perfect. So this code by Elango is also working perfectly fine. Here he has made use of 2 for loops. I have made use of only 1 for loop. So this is a different way. I have used 1 for loop and 1 if else condition. He has used 2 for loops. Then someone else is giving some other suggestion. Let me check. Okay, someone is asking for the YouTube link. Let me share that. So whoever wants the YouTube channel, that's there. Then someone else, Ravali, has some other suggestion. Let me see that. Ravali, do you mind copying, means typing that thing out? It or should, okay, fine, I'll type it in Spider. Okay, so this is Ravali's code. This was Elango. It's fine. My code is fine. Now let's comment this as well and try Ravali's code. So I'm typing out Ravali's code. It's a really big piece of code. Just give me a minute. So Ravali, one thing I can just predict from this code itself, that each of your star will be printed in a new line because it is there inside the for loop and you have not used end equal to.
Yes, ma'am. I forgot.
And so I'll just show that. That's the problem when you have for loop. So what is this after I equal to n, what you have written?
Float division, ma'am. Integer
Okay,
division by 2.
fine. This. Okay, so this is one piece of code. Let's run it. Why it's showing error? J equal to. So first thing, Ravali, you have written is wrong is you have to use double equal to when you are using in the if condition, when you are checking for it. You can't use just a single equal to. You can't use this if j equal to. You have to use this double equal to for
Yes,
checking.
ma'am. Yes, ma'am.
Okay, so one has to be very careful. Single equal to is for assigning and double equal to is for checking. So let's do this. See, all the stars are coming in a different line. So if I count the number of stars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I am getting one extra star also, because I should get a total of 9 stars. If n is 3, then you see 1, 2, 3, 4, 5, 6, 7, 8, 9. A total of 9 stars should be there. Here there are 1, 2, 3, 4, 5 and 10. So this piece of code is not working. You should try and think of some different method. But anyway, we have two
Okay, ma'am.
ways over here. Either this one or this one. These are the two ways right now which are working perfectly fine. Okay, so let me come back. Oh, I mean, there is nothing to write. I'll just erase all of this and write the correct piece of code for you. Okay, so yeah, I got rid of all the wrong stuff. Then the correct thing is, so this is the correct piece of code and we have checked it. Fine. So this brings us to not just the end of this video, but the end of the course. I hope all of you had a good time in this course, and I believe all of you have learned decent amount of programming using Python. And if you want, you are now basically ready to venture into the world of programming and try out new things on your own. So now you can basically watch different videos, different courses, and take help of different resources to write programs for your own kind of applications that you want to do. So thank you very much and hope to see you in some future NPTEL course. So once again, for those of you who joined late, this is the YouTube channel where all these live sessions are available. Okay, thank you. Bye bye.
Okay, ma'am. Thank you, ma'am.
And all the best for your exams. All of you will do well.
Thank you.
Thank you. So yeah, the class is over. All of you can leave.